Ukraine, summer 2023. A Shahed 136 drone crosses the border at 185 kilometers per hour, 30 meters above a river valley. Low enough that radar returns blur into ground clutter. The terrain is hiding it. A ZSU-23-4 crew picks it up on passive cameras. No radar running, 4 barrels, 3,400 rounds per minute. The drone is gone. The vehicle that just stopped it was designed when Khrushchev was still in power. This is not a relic, it's an air denial machine, and 3 countries are currently paying to rebuild it from scratch. In a minute, I'll show you the design logic that made it lethal in 1973. And then I'll show you exactly what's being done to it now, and why those changes are more interesting than the original. This is the story of the ZSU-23-4 Shilka. Built to deny low airspace over Soviet armored columns, officially replaced in the 1980s, and now being completely rebuilt to fight the most common aerial threat on Earth, a cheap drone that costs less than a car. To understand why this gun exists, you need to go back to the late 1950s. NATO's plan for stopping a Soviet ground advance depended heavily on low-level jet strikes, fast aircraft below radar with exposure windows sometimes under 2 seconds. The Soviet system designed to counter that, the ZSU-23-2 fired 2 57mm guns at a combined 100 rounds per minute. Against a crossing jet in a 2-second window, you got one short burst. You either hit it or you didn't. They needed a different philosophy entirely, not a better gun, a different answer to the problem. The engineering problem, starting in 1957, fire volume to handle the short engagement window, tracking speed to put rounds on a jet speed target, and all of it on a vehicle that could keep pace with tank formations. Most systems get 2 of those 3. The Shilka tried for all of them. The way it did, it was not obvious. The core insight against a fast low-altitude target, no fire control system, in 1964 could guarantee a hit with a single round. So the designers stopped trying to solve the accuracy problem and started solving a probability problem instead. 4 23mm water-cooled barrels. Combined rate, 3,400 rounds per minute. Not precision. A corridor of metal the target has to fly through. The 23mm round is relatively small for an anti-aircraft gun. That was deliberate. Smaller round, lighter ammunition, more of it on the vehicle. The Shilka carries 2,000 rounds. A 3 to 10 round burst at 1,500 meters creates a spread wide enough that a crossing jet cannot exit it in time. Here's the part most people miss. The crew's job was not to aim. The RPK 2-to-ball radar locks a target within 30 seconds, and the onboard computer calculates lead angles for each burst. The gunner confirms the target. The system handles the geometry, track to fire in under 4 seconds. And because the whole system sat on a chassis sharing components with the PT-76 light tank, it could fire and move without ever leaving the column it was protecting. No deployment phase, no gap in coverage. NATO had built its low-level strike doctrine around a gap. Soviet air defense could push jets high, where missiles waited, or leave them low, where guns couldn't reliably hit. The Shilka closed the bottom of that gap. In October 1973, Egyptian and Syrian forces deployed Shilkas alongside SA-6 surface-to-air missiles. The SA-6 forced Israeli aircraft to drop below missile altitude to survive. The Shilkas owned everything below that altitude. The IAF, one of the most combat-experienced low-level strike forces in the world, flew directly into a layered kill zone and suffered severe losses. It wasn't either system alone. It was the combination that removed every safe option. That insight shaped anti-air doctrine for the next 30 years. If you like these engineering breakdowns, subscribe. Now let's get to the part the title actually promises: what's being done to this gun right now and why the changes matter. The Shilka was brilliant, and it carried a quiet penalty. The gun dish radar has a hard floor. Below roughly 60 meters, ground clutter overwhelms the return. Against something flying genuinely low, the system goes optically blind in poor weather. The Soviet Army hit this problem in Afghanistan and solved it bluntly. On the 1978 Afghan variant, they removed the radar entirely, added a night sight, and doubled the ammunition load to 4,000 rounds. The most sophisticated component of the system stripped out. That decision would turn out to be more relevant than anyone expected. The second limit, 2.5 kilometers effective range. By the mid-1980s, standoff munitions were already pushing threats beyond that. The Shilka was being engineered out of its own kill zone. Production stopped in 1982. The two S-6 Tunguska replaced it in frontline units. By the 1990s, it looked like a closed chapter. When the Cold War ended, the Western approach looked like it had won. The German Gepard used twin 35mm cannons with sophisticated tracking radar, more accurate at range, better sensors, higher unit cost. The broader Western doctrine was the same: fewer systems, more precision, invest in sensors. The Soviet philosophy was the opposite: build enough of them, keep them simple enough to repair in the field. The Shilka's 23mm round was less lethal than the Gepard's 35mm, but 6,500 Shilkas were built. The Gepard topped out at 420. For 30 years, precision looked like the right answer. Then the question changed. A Patriot interceptor costs over $3 million. Each Shahed 136 costs Russia around $35,000 to manufacture, according to the Center for Strategic and International Studies. That is an 85-to-1 cost exchange every time Ukraine fires a Patriot to stop a drone. By March 2025, Russia was launching more than 1,000 Shaheds per week. Missile defenses were burning through inventory faster than Western factories could resupply them. The problem wasn't capability, it was arithmetic. Gun systems, cheap ammunition, high rate of fire. The Shilka's entire philosophy, volume over precision, was suddenly the correct answer, and dozens of countries already owned the platform. Three countries have rebuilt the Shilka from scratch. The chassis and barrels stay. Everything that tells the system what to shoot at is replaced, and each country solved that problem differently. Poland, the Biała, make it invisible. The ZSU-23-4 MP Biała, adopted in 2005, stripped the radar out entirely and replaced it with a fully passive electro-optical system, thermal imager, daytime camera, automated tracking computer. No radar emissions means nothing to detect, nothing to jam, no signal broadcasting the vehicle's position. Against drones increasingly carrying EW payloads designed to home onto radar emissions, that is a counter-EW advantage, not a downgrade. Grom missiles added to the turret extend the engagement range to 5.5 kilometers. Crew reduced from 4 to 3. Around 20 were sent to Ukraine in 2023. The Afghan variant in 1978 removed the radar because terrain made it useless. Poland removed the radar in 2005 because modern threats make it a liability. Same answer, different reason, 60 years apart. Azerbaijan, the 8X 2024 rebuilt. Add what was never there. Revealed at the 8X 2024 exhibition in Baku, 23 Azerbaijani Shilkas were rebuilt in collaboration with Elbit Systems of Israel and CSG Defense of the Czech Republic. The new radar tracks 100 targets simultaneously. The original gun dish tracked 1. Elbit's Coaps-L electro-optical system provides independent visual verification. A fully digital fire control computer replaces the analog system. The gas turbine engine replaced with a Lombardini diesel. GPS navigation added. The chassis is from 1965. Almost nothing inside it is India, phased array radar and live combat proof. Bharat Electronics Limited replaced the gun dish with a 3D active phased array solid-state radar with electronic beam steering, the same fundamental technology in modern fighter jet radars, mounted on a 1960s chassis. All-weather day-night electro-optical tracking, ECCM, built into the radar. The gun's cleared for proximity fuse ammunition, which detonates within lethal range of a drone rather than requiring direct impact, fundamentally changing hit probability. In May 2025, upgraded Indian Shilkas were used in live counter-drone operations along the line of control. Over 50 drones neutralized across a single series of engagements. One Army officer and a colleague also integrated an indigenous electronic jammer directly onto the platform in under 10 months, giving it the ability to jam a drone or shoot it down depending on the situation. Back to Ukraine, summer 2023. A Shilka with no radar running, passive cameras, and a 1960s lead-angle computer kills a drone that costs 85 times less than the missile that would otherwise have stopped it. The gun is 60 years old. The logic is current. That's why the Shilka was never just an anti-aircraft platform. It was proof that volume, mobility, and cheap-to-sustain firepower can beat precision if the threat is cheap enough and numerous enough. For 30 years, the threat wasn't. Now it is. The question is no longer whether the Shilka still works. The question is which Cold War system gets rebuilt next. Drop your answer in the comments.